It's incredible when you think about it. We went from a single, almost philosophical question posed by one brilliant mind way back in 1950 to a technology that's now in the hands of hundreds of millions of people. This is the story of artificial intelligence, and it's a wild one. A 76-year journey packed with impossible dreams, spectacular failures, and then a sudden explosion that really did change everything. Okay, let's get into it.
So where does a story like this even begin? Well, it's not with a humming supercomputer or a shiny robot. Nope. It all starts with a question. A question that was so profound, so challenging to what we thought it meant to be human, that it kicked off a scientific quest that would last for decades.
And the person who asked it? None other than Alan Turing, the legendary codebreaker. Back in 1950, he wasn't just daydreaming. He was essentially throwing down a challenge to the world. He wanted to know if we could actually build a mind from scratch. But he was smart enough to know that a word like thinking is, well, it's impossible to define. So he did something absolutely brilliant.
He just changed the rules of the game. He said, look, forget trying to define thinking. Let's just focus on behavior. The idea was simple. Can a machine have a conversation with you that's so convincing you can't tell if it's a machine or another person? If it can, well, for all practical purposes, isn't that intelligence? That simple, practical idea is what gave birth to this entire field.
And just like that, the race was on. In 1956, at a famous conference at Dartmouth, the term artificial intelligence was officially coined. And the founders, they were unbelievably optimistic. They honestly believed that human-level AI was maybe just a decade or two away. That optimism kicked off what we now call the Golden Age, a time of massive funding and sky-high hopes.
And for a little while there, it really looked like they might be right. Some of the early programs seemed like actual magic. In 1966, you had Eliza, a chatbot that acted like a therapist. Some people were genuinely fooled into thinking it understood them. Then there was Shrudlu, which could understand commands about a virtual world of blocks. And Shaky, the very first robot that could actually look at a room and figure out how to navigate it on its own. The future was here. Or was it?
Here's the catch. All that early magic, it was kind of an illusion. The incredible demos that got everyone so excited were hiding a really fundamental weakness. These programs were incredibly brittle.
So the promise was this grand human-like intelligence. But the reality? These programs only worked in what researchers called microworlds. Think of it like a movie set. Eliza just recognized a few keyword patterns. Shrudlu only knew about its own little world of blocks. The second you took them out of their tiny, perfectly controlled sandboxes, they just fell apart.
And when the world realized that huge gap between the promise and the reality, the whole thing came crashing down. The funding dried up, the media lost interest, and the best researchers left the field. This was the very first AI winter, a deep freeze that would put the dream on ice for years to come.
And believe it or not, this happened twice. You can see it right here. The first winter in the 70s pretty much killed that original dream of logic-based AI. Then things kind of thawed out in the 80s with these things called expert systems, which were basically huge, complicated rule books for specific jobs. But they were also too rigid and expensive, and boom, a second winter hit. But look at that last column, the hidden hope. Because during both of these deep freezes, a few really dedicated researchers kept a little flame alive. They were working on a different idea, one that almost everyone else had given up on: neural networks.
And this right here, this is the pivot point for the entire story. The whole approach to AI was about to flip on its head. See, the old way was trying to hand code all the rules for intelligence. But how do you write a rule for recognizing a cat or understanding sarcasm? It's basically impossible. So the new idea was, what if we just stop trying? What if instead we could build a system that learns on its own, just by looking at massive amounts of examples?
So that brings us to the big, obvious question, right? This idea of learning from data had been floating around since the 60s. So why, after decades of failure and disappointment, did it suddenly just work? What was the secret sauce?
Well, it wasn't one thing. It was actually three key ingredients that all came together at the exact same time. It was the perfect storm. First, the internet. Suddenly, we had unimaginable amounts of data, texts, images, you name it, for these systems to learn from. Second, computing power. And get this, it came from gaming. Graphics cards, or GPUs, turned out to be the perfect kind of hardware for training these networks. And third, the algorithms just got smarter, finally letting us train these really deep, complex systems. And when those three things combined, Boom! We got the big bang of modern AI. In 2012, a neural net called AlexNet just demolished the competition in an image recognition contest, proving this stuff really worked. 4 years later, AlphaGo beat the world's best Go player, something people thought was decades away. And then, in 2017, came the real game changer, a research paper from Google on an architecture they called the Transformer. That's the blueprint for pretty much all the AI we use today.
Once the transformer was out there, progress went completely vertical. In 2018, OpenAI released GPT-1. It had 117 million parameters. You can think of parameters as the little knobs in the AI's brain that get tuned during learning. And back then, 117 million was a massive number.
But just hold on, because only 2 years later, they released GPT-3. And look at this number. We went from 117 times million to 175 billion. It was over 1,000 times bigger. And suddenly, it could do things nobody thought was possible, like writing poetry, creating code, and generating text that was just human.
But all of this amazing stuff was still mostly happening inside research labs. Then came November 2022. OpenAI took that incredibly powerful GPT-3 engine, put a simple, easy-to-use chat interface on top of it, and released it to the public, for free. And that one move changed everything.
The response was unlike anything the tech world had ever seen. I mean, look at this graph. 1 million users in just 5 days. 100 million in 2 months. It became the fastest-growing app in history. Why? Because for the first time, anyone with a laptop could have a real conversation with a world-class AI.
And that release just opened a floodgates. The pace since then has been absolutely breathtaking. Now we have things like GPT-4, which can see and analyze images. We have Claude, which is focused on safety and can digest an entire book in seconds. We have Google's Gemini, which was built from the ground up to understand not just text and images, but audio and video too. And we're even seeing the dawn of AI agents, systems that don't just talk, they can actually do things for you.
But okay, let's take a breath, because the journey is far from over. For all their amazing power, these systems still have huge challenges. They have this weird tendency to just make stuff up, and we call that hallucination. They soak up all the biases from the human text they're trained on. And maybe the biggest challenge of all, we don't fully understand how they make their decisions. Figuring out how to make them safe and controllable is one of the most important scientific problems of our time.
And that brings us right back to where we started. Alan Turing kicked off this whole 76-year journey by asking, can machines think? And now we have systems that, by his own definition, have passed that test with flying colors. So the question for us is no longer if they can think. The question has changed. Now it's, how do we live with thinking machines?
The first leg of this incredible odyssey gave us the answer to Turing's question. But in doing so, it left us with a whole new set of questions, questions that are far more complex and far more urgent. The next chapter of this story is the one we are all writing together right now.